Problem 121, best time to buy and sell stock. In this problem, we are given a set of prices that represent a single stock's price on ETH day, so day 0, day 1, day 2, etc. Now, we are allowed to purchase stock at some one time and then sell stock on the same stock, obviously, on one of the days in the future and make profit. So the question is, what would be the maximum profit we can make from that sort of transaction? Now, potentially there are almost, let's say, n squared number of different segments where we could buy and sell stock, right? It's probably what? N minus 1 times half of that. That's how many different segments there are for buying and selling stocks. Now, can we do slightly better? And I would propose that we could basically do the following. If we just focus on this day, the day when the stock will be sold, and try to find this day, we could just traverse the array into this direction and examine each day from the beginning and see, are we looking at the best day to sell the stock? Okay, so that's the idea. And why is this useful? So imagine that we've already covered part of the array, and we've studied and we've examined this part of the array. We've made some conclusions so far. And now we've moved to the next day. So here's the price today. That's the price we're looking at. And the question is this a better option to sell the stock than any other day that we've encountered already? What information would we need to make that decision, whether this is a better option to sell the stock? So if we had the following two pieces of information, that would be really helpful. One would be, what is the minimum price so far? Minimum price that we've encountered so far. Well, that would be pretty helpful if we knew that. And we can easily just remember the smallest price so far. Second bit of information would be, what is the maximum profit so far? Again, so far. So if we somehow know the maximum profit, if the sales date was somewhere prior to today, somewhere prior to that, what is the maximum profit? So then we could easily decide whether today is the best day to sell, because we could make a decision. Obviously, the best profit we could make today would be to buy at the minimum price, sell at today's price, and then compare it to the maximum profit. Okay, so to implement this, let's think about two variables. So one would be minimum price so far, let's call it min. And then the second variable would be, let's call it profit, would contain maximum profit so far. Probably we should initialize profit with 0. Probably doesn't really matter. Well, it matters if there is no transaction. If we do not decide to make any transaction, then probably profit will remain unchanged and we'll return that. So we want to set this to 0. Now, how should we initialize min? Now, min should be the worst possible price, so that even when we look at the first day, we are never tempted to decide to sell that stock. So minimum, let's say if the price was infinity, right? If the price was positive infinity, if we set min to plus infinity, then when we look at the first day, we'll never decide, well, today is a great day to sell the stock if we had bought it at the infinite price. So we would not decide to do that, and we would reset all min and profit so that that would not happen, right? So that sounds quite reasonable, at least to me. We'll see if we can implement this. So we said basically let's have two variables. Minimum price would be, we said, plus infinity. And then, well, we don't really need this plus. This is just for mathematics. And then maximum profit so far, we said we'll set this to 0. Now we're going to go through every day, every price of prices, and say, what should we say? So minimum price would be, right? Let's set it like this. So what that will achieve is, if we have obviously the minimum price so far, which is initially really big. So from the price so far and the current price today, we'll choose the minimum, which is, well, best price so far, including today. Now, if we have that, now we should, so we have profit so far. And then what we could achieve is we would take today's price minus this new minimum price, right? And then we could say take maximum of these. If we take maximum of these two numbers, profit so far and profit that we could achieve by selling today, right? Then that would be our best option. So this is the previous profit is better. This is selling today is better. So whichever of them returns a bigger number, then we're gonna keep that inside profit. And after the loop, we're gonna return profit. This is done. Let's try this. Okay, cannot find price. Sure, of course. Let's see. Now, this passed pre-tests. Let's try on the actual tests. The full suite of tests. Okay, I think we also passed this. Do not remind me today. 8 milliseconds. It's not the best performance. Should we try to rewrite this in C++ and see? So 8 milliseconds, 66 megabytes of memory. Let's try to rewrite it in C++ and see what happens. So max profit. We're going to do min is what is it? Int max, right? And then integer min is that, and then profit is 0 for price of prices. Int I equals, oh, actually I could do price of prices, right? Int price of prices, and then min would be maximum out of, oh, sorry, minimum. Min would be minimum. Oh, that is not nice. STD. So are we gonna have a clash of names? And then profit is maximum of profit and price minus min. And here we return profit. Rid of this. Let's see what happens. Okay. All right. This should be inside the function. Right, these are accepted. Let's try to submit this. Five milliseconds. I think this is better, right? Slightly. It's still not a stellar performance. I'm not sure how is this significantly slower than anybody else's, but well, okay.